So welcome to the video where I'm going to show you how to modify the code written by VK3BHR for a frequency counter, which I have discussed about in the instructables. So let's open the MPLAB IDE here. Well, the reason why I'm using these virtual boxes is because I'm running Windows 7 in them, and the MPLAB IDE runs better on to me it seemed like that it runs better on the Windows 7. The reason why I'm using MPLAB IDE, not the MPLAB X IDE, is because after doing some research online, it seemed like the assembly language program can be done more efficiently on the MPLAB IDE instead of doing it on MPLAB X IDE. And there are certain other things that I'm not going to discuss about here. So let's get into modifying the code. Well, most of the modifications that I have done are based on the comments that VK3BHR added while writing the program, and I'm thankful to him for that. So here you can see comment out the next line if using 16F628. So I have commented out the next line, define F84, and you can see that in the circuit that I made, I used the 16F628A instead of the 628. It's like it doesn't matter whether you use 628 or 628A because they are identical, except I think, I don't remember properly, but 628A has an internal oscillator, whereas 628 doesn't have one. That's it. So that's the first modification that I made. Then comes the second modification, for which I had to modify more things actually. Yep, here we go. And well, I'm sorry for the time that is taken. So here you can see that in the original code there was only one dot placed after 1 sub-megahertz. I thought that it would be helpful to read the display if I placed another dot after 1 sub-kilohertz, which you can see, which you can see here. I added an extra dot after 1 sub-kilohertz, which made the display in megahertz, kilohertz, and hertz format. It actually helps to read the frequency more rapidly if you have the megahertz, kilohertz, and hertz separated. So this lines of code helps to add helps to add a dot after 1 sub-kilohertz. Now, that's how the display looked like before adding the dot, and that's how it looks like now. Now, after I added this dot, there came a problem actually, which was here you can see already why people don't like don't write codes in assembly language anymore unless very much needed. They are huge actually. Anyway, so after after I added this dot after 1 sub-kilohertz, there came a problem. It's like the original counter which VK3BHR used, made, had a 16 by 1 LCD display, whereas I'm using a 16 by 2 LCD display. So when I added this dot up to 1 sub kilohertz, there was not much room left actually to include those. This is how it looks like right now. After I added that dot after 1 sub kilohertz, there was not much room left to print this USB LSB program and cal suffixes. They are printed when you are using the counter in these modes actually. So I had to somehow shift that these characters, the USB LSB program and cal, to the second line of the LCD display, which is like the reason why I had to shift that is because, after leaving a space here up to megahertz, I was left with only 2 characters, 2 blank spaces on the first line. So even if I tried to keep that in the first line of the code, it was not possible to do that. I was printing only 2 of the 2 letters of the suffixes, only US, LS, PR, and CA of these letters, so I had to somehow shift it to the second line. So what I did was, I'm not going to show it to you, you can understand it. I'm going to supply this modified code anyway. So I basically called line 2 a function defined by VK3BHR himself. I called line 2 function, which basically placed those USB LSB program and cal to the second line of the code. And I don't have a picture showing these suffixes being printed on the screen, but I have one picture. Yeah, here we go. I basically placed this huge spaces, huge spaces before these suffixes, because I basically wanted to place those cal USB LSB and whatever it was USB LSB program and cal on the left, it's bottom right corner of the screen. It made it look better actually, that's all about it. It doesn't have anything fancy. It is all about being fancy, alright? It doesn't have anything to do with any kind of problems. So when I modified the code to shift these suffixes to the second line of the code, I was not able to clear those. Basically, when you use these functions, this text appears on the screen, but once you're done using those functions, they are supposed to disappear from the screen. But when I made the modification and I called line 2 function, it basically was like even after I was done using these functions, I was not able to remove these suffixes from the screen. So with the help of LED tester from EEV blog, I basically modified, I basically did nothing, alright. LED tester helped me, and he added this function which keeps the second line of the LCD display clean all the time. What it does is, when you are using these functions, they get printed on the screen, but when you remove the condition, which is like placing a jumper between pin 10, 11, 12 and 13 of the PIC to ground, when you remove that jumper, these suffixes are cleaned from the screen. That's the idea behind it. And here you can see I modified the code. I added this frequency counter and DOM 13C to the code, whereas in the original version there was FM009 and VK3BHR. I'm sorry, VK3BHR if you're seeing this. But yeah, I modified that so that I can show this thing when I turn on the counter. Basically, this text string is shown when you are turning on the counter, and it stays on the screen for like half a second. So if you want, you can edit this code and place your own name or whatever you want to here. And basically that's all about all the modifications that I made. So after you're done modifying your code, in case you do anything else, you can click build all and release. You have to be cautious. You have to be building the whole project in release mode, otherwise you won't have the hex file that you're going to use. This hex file that you're going to use, it will not be generated if you are building this in debug mode. You can see here only the MCP, yep, it doesn't generate the the hex file. So that's it. You can see the hex file is being generated. So that's all about it. Hopefully you understood all of the things that I tried to say here. If you didn't understand, you're welcome to make a comment. I'll try to reply to a comment. If I can't, I would be sorry, because if I can't, pardon me, because I'm a student and I have a lot of other things to do. So thanks for watching.